Hello everyone, this is Eren Şahin. I'm a sales engineer from liNear. Today's topic is construction and calculation of ventilation systems with linear solutions on Revit. I will use linear desktop ventilation and analyze ventilation modules in this webinar. With linear desktop ventilation module on Revit, you get a perfect tool for the construction of your MEP model. Not only the comfortable provision of our tools, but also the sorting, bundling, and simplification of the Revit functions is our approach. With linear view creation commands, you can easily create views and switch between them. With organized product libraries, you will have a wide variety of air outlets, protective gratings, and components for round, oval, and rectangular ducts such as sound absorbers, fire dampers, fans, and volume flow rate controllers. And you can select these families in between generic or manufacturer-specific components. There are automatic connection and routing commands, and also commands for detecting and resolving collisions. liNear Analyze Ventilation module will help you with determining the volume flow rates, pressure drops, as well as hydraulic balancing. They are calculated according to the previously defined basic conditions. Additionally, on the basis of the same model, a detailed calculation of the sound level development for each flow path is being performed. For all components, both internal sound and absorbability in the octave bands are calculated according to the V21. The duct network calculation is directly integrated into the CAD model, and there is no interface between construction and calculation. By this means, there will be no problem with data exchange, and redimensioning based on calculation applied directly into the model, and calculation results are automatically written into the model. When you get your results, you can easily have legends, outputs, and material list. And here you see the ventilation workflow of liNear. When you receive the architecture as a Revit model, liNear will use all elements such as levels, rooms, and materials, and you can add further information into the architectural components. After you add this information, you can easily determine volume flows with liNear tools. You can do this for each room, and air outlets will be dimensioned on the basis of this volume flow rates. And then you construct the duct network, including all components such as sound absorbers and fire dampers. The linear duct functions and the command for automatic connection allows you to construct very easily. Supplied manufacturer libraries allows you to design with objects that are actually available. You have the choice between our linear configurator or the device configurators of our industrial partners in order to create the central air handling units. When you construct the duct network, you can apply hydraulic calculations on it. liNear will determine the optimal dimensions of the system and calculate pressure losses. The system is also analyzed in terms of acoustic aspects. All calculation results can be visually checked with data coloring, and these results will be saved into your components according to your company's shared parameters file. When you finish planning, you can easily have duct network calculation results, sound level calculation results, and bill of quantities in 7 different languages. liNear gives you the most innovative and technological tools for MEP BIM design. It offers you a systematic workflow that eases the whole planning process and prevents error in every step with high precision calculation results. This is why liNear is used in very big projects worldwide. Our customer Tilke from Aachen used linear solutions in racetrack Yas Marina Circuit project in Abu Dhabi. In addition to the truck infrastructure, they were also responsible for all associated construction measures. Tilke Engineering is regarded as a world leader in the planning and realization of racetracks, and they have been consistently relying on the design and calculation software from liNear for all building services for over 10 years, and the entire technical building equipment for the Yas Marina circuit was planned with liNear software. The ventilation system of pit stop boxes were calculated with the module Analyze Ventilation, which I'm showing you today. This is a very important task, and it needs precise calculation because of high concentration of exhaust gases and necessity to protect technicians inside. The entire area of the project is 161.9 hectares, and Tilke itself employed 120 engineers and architects on site, working with 17,500 workers on the circuit and another 5,700 on the hotel complex, and it took 30 months to complete the project. Now let's start our live demonstration. First we start liNear on Revit and we open our project. This is the Revit interface and you see the liNear control board on the right side of the screen. You can see all stories, building parts and views are recognized by liNear and you can switch between them very easily. Now we will create the view where we will draw our ventilation system. For this, we will select the building part, the story, the discipline, and the type of the view. We only have the ground floor, so we select floor plan. Now we click on this little plus sign in here, and as you see there are other options in here. You can make this view usable for another discipline, or you can select multiple story to create views for each. And also you can select the level of geometry that will be used in this view. Then we click on the create view. Now we start with air outlets. For this, we move to the library tab. First you select the construction level. You select the reference story and then you enter the value. Either positive to make it higher or negative to set it in lower height from the reference story. In here you can either use families with manufacturer data from liNear CAD browser or use generic families. First let's check out our liNear CAD browser. As you see, there are various manufacturers that produce components for different disciplines. If we select the Wildeboer, you'll see there are different families in different titles. They are manufacturing ventilation components, so there are duct components such as volume flow regulators, fire protections, or sound absorbers, and also there are air outlets. When we select air outlets, it will ask us to choose between protective gratings and sealing air grills. And inside of sealing air grills, there are different types and shapes. When you select one of them, yes, and you will see different options. Between these options, you can select exactly the same component that you will use in your project with corresponding technical data, and you can place it with the level of detail that you select in here. You can select either detailed or simplified view of this component. Also, you have some options to insert it into the project. You can directly place it, you can insert it to a duct, or you can replace it with a generic family. Now let's go back to our CAD screen. Here we will select an air outlet in between the neutral components. When you click on it one time, here, when you click on it one time, it will be installed into the project. When you click one more time, as you see, it will be on the crosshair. So you can place it wherever you want. We also have one more comment in here, and it's very interesting. When you select place on grid command and then select the component, the command will ask you to select 3 corners of the room that you will insert this component. When you select corners, a new dialog will pop up and there are different placing options in here. This is very easy to use. You can enter distances from edges and write number of elements and it will place them on a grid formation. It is very similar to the array command on AutoCAD. Now let's start to input our variables. So start with the number of elements. We have 6 columns, 2 rows. And for the edge distancing, we say 5000 from right, 12,000 from top, 7500 from left, and 4600 from the bottom. And now you see the formation as a preview in this screen. And when you click on OK, you see all the air outlets are implemented and drawn into our project. Now we will draw our duct network. In order to do this, we open the construction tab. As you see, the construction levels stayed the same as we selected earlier when we were placing the air outlets. Under this title, there are different kinds of duct types. We select the supply air and we open the ducts dialog. We can select the dimensions of the duct system in here and also the height reference and orientation for our drawing. And then when we activate this command, we can draw our duct. This. As you see, our duct is drawn. Here we also have parallel pipes command. With this command, you can set up a configuration with different kinds of ducts and pipes with given diameters and distances. You can also set references for these distances too. When we open configurate, we see there are 2 types of pipes are added into this configuration. We delete this configuration and select our exhaust air. You'll see there are different options for this duct, and we can select its diameter, and we can set up a distance. We can also set an insulation, and when we click on OK, you see it's added onto this list. And when we activate the command, parallel pipes command, when we select these ducts and press on enter, it will show us different variations to put this other duct into our ventilation system. It shows us 4 different options. The first one it's on the left side of this duct, and the second one is on the right side, on top and the bottom of this duct. There are, as you see, different drawing options, and when we select one of them, it will be drawn into our system. Now let's continue to draw our exhaust duct. In order to do this, we click on this draw duct command, and then we continue this construction. We create this collision. And now we will connect our ducts to the air outlets. For this, we will use connect components command. It's right here. Under this command, there are various options. You can set a connection type for TPs or ports. When you change it, as you see, this preview is also changing. You can use flexible ducts, and you can set a length for them. You can also add a built-in part for each connection. In here, as you see, there are different kinds of duct components such as coolers, sound absorbers, filters, and so on. And if you select this option, this one, bands on the last components will be activated. Under these, there are also automatic connection and T-piece connection commands for ducts or ducts to components. There is also a command for legends. In the legends dialog, when you open this dialog, you can easily select the elements and systems that you want to see in the legends list. You can also set a text style in here and headline for this page. You can arrange and rename all elements that you used in the project. When you click on OK, as you see, it will create a legend page for the system. With this pipe offset command, you can find solutions for collisions. For example, we have a duct collision situation going on in here. And under this command, there are different options that you can set a distance for X and Y. For pipes, you can use existing fittings to prevent the extra cost, and there are different drawing modes that you can select between. In here, as you see, you can offset around elements, you can offset around linked elements, and you can do all this manually. So you can use the linked elements if there's a linked architecture file and there are elements in there, and you can use this command to offset around them. Now let's try this command. We activate the pipe offset. First we select the duct we want to offset on, and then we select enter, and then we select the other duct, and when we click on enter, you see there are two options to create this offset, and when we apply, as you see, the command in here is applied for our system. When we look at the situation a little bit closer, you see this offset has been created. Now let's go back to connecting our components. I already showed you the details of this command. Now we will apply this into our calculation. But first we need to rotate all these components to the duct in the middle. In order to do this, liNear has a very practical command to turn components by 90 degrees. We can select multiple components like this. When we click on this command, as you see, all of them turned by 90 degrees in one time. And now we will connect all these components. Of course, we should select ports and activate the command. And we select everything and click on enter. You see all of them are easily getting connected to the duct system. And now we will complete our exhaust air system. We click on our duct and then click on draw duct command. Then we draw our duct until here. And we open the library tab, and then we will select an air grill from here. As you see, there's an air grill. We select this as an inflowing one, and then we just put them on our exhaust duct very easily. As you see, we can easily, when we click on space, it will rotate the component as we wish. Yes, you see it. Yes. And we placed all air grills into our exhaust air system. Now we have our duct system and air outlets, and it's time to create the air handling unit. In order to do this, we go back to our library tab and open the configurator. We see there's a ventilation device configurator. When we click on it, you will see this dialog to create our air handling unit. In the configurator, first we give dimensions for upper and lower levels. Here, as you see, they are already determined as 800, 850. On the screen, when we right click and click on New Component, as you see in this dialog, there are different kinds of components. It includes all components that can be used in air handling units. After you select your component, you can select the type in here and dimensions from here. Every component has its own type. For example, if we select an heat exchanger, in here there are generic cross-flow and rotation heat exchanger types. Also, you can set connections for this component. When we click on Add, it will add this connection right here. You can set up the type of the connection to position and geometric data for the position and dimension of it. For example, if we change the type to round, as you see, it is changed to round, and you can see it on this preview. And when you change the position, it will change its position on this preview. And when you click on OK, it will add this component to your configuration. You can add more components like this, and you can easily create your air handling unit. And right here you can reverse the air direction for each levels. Also, you can select if it's a horizontal or vertical construction. If you click on this, it will set this to horizontal construction. After you select all components, you can save this configuration with .xml format and load it into other projects. We already have a configuration, so we will just load this for this sample. As you see in here, there are loaded air handling units. And when you click on yes, you see our configuration is right here. And when you click on OK, it will add this air handling unit to our project. But there's a problem, because our construction level was up to 4,800, so we need to change it first to 0, because we will place this on the ground. And yeah, right now we can place it in any direction we want and any place we want in our project. And now we will connect our ducts to the air handling unit. While we are doing it, we will use liNear's automatic connection commands. So first, we should create a 3D ventilation view. And we will hide the architecture. See it more clear. The automatic connection command is also like the pipe offset command. It will give us different variations, different options to select between them. And we will select the most appropriate one to create our construction. So we have our air handling unit. These are different types of ducts with different dimensions. And we will use this automatic connection command. We select this duct and the supply input of the air handling unit. Now we see that it gave us three options. See, this is first one, this is second one, and this is the third one. And when we apply, it will connect our system to the air handling unit. And now we try with the exhaust air, and with this one it gave us 10 different options, and we can switch between them to find the most efficient one. And we select number 4. Yeah, this way we applied it, and you see that our connections are made very easily. Of course, at the model there's a serious difference between dimensions of the our ducts and this air handling unit, but we already draw our duct system neutrally, so we didn't give any dimensions. Linear analyze module will calculate all these duct dimensions or diameters in advance in our hydraulic calculation part. So now we will continue to draw our outside air and escaping air system. First, we make the architecture visible like this. Now we continue with the drawing of outside air duct. In order to do this, we click on this, and then we start drawing, and we give it some elevation. Draw it like this. As you see, this is also drawn as a supply air duct. To change it, we select this duct, and then we go to the construction tab, and then we select outside air system class, and we apply this. As you see, the system type has been changed. And now we go back to the library tab and select the rectangular protective grating with inflowing, and then we put this component right here. And now we will continue with the escaping air duct. To this we draw from here, and we give it elevation as 8000, and when we apply it, it's already drawn. Also, we can easily insert built-in duct components. We can choose any component from the library or the CAD browser, and we can insert them in. When you scroll down to rectangular built-in duct components and you expand this dialog, you will see a wide variety of products. So let's select a cooler. First we install it into the project, and then click again. And when we select our duct, as you see, it is inserted into our ducts, and its technical data will be calculated with Analyze Ventilation module. Now we will apply our hydraulic analyze. For this, we open our final project. First, we start with the rooms command. We go to the Analyze tab and click on Rooms command. Here we can see all rooms exported from the model. You can select parameters that will be exported into this calculation. When we select the room, we can see all geometric and thermal properties for the room. You can also select the spatial property and the room type for sound level calculations. Here you can see all air outlets in this room. They are automatically taken, but volume flow rates are not set. We have different ways to calculate the target value. We can select the minimum flow rate based on DIN EN 16798 standard. We can select the category and the building emission. The value for minimum flow rate will be calculated. We can also set target values for room loads. In order to do this, you need to calculate the room loads first. Our room loads are already calculated with linear building analysis models. After that, you need to input a value for supply air heating or cooling temperature. After you give this value, volume flow rates based on loads will be calculated. Now we have different target values. We make the selection for the target value that we will use in our project from here. You can either select the minimum flow rate, heating, cooling, and the maximum will be the maximum in these values. And when you click on this calculator, it will calculate volume flow rates for each air outlets. Also, sound level calculations in here calculated based on the room type that we select in here. And now we will calculate the system. We will click on calculation. As you see, the calculation dialog has popped up and it's categorized in 3 titles. There are flow paths, section parts, and components. And also we can do the system selection from here. Under flow paths, we can see the flow path from the source to the consumer, and the critical path is marked in yellow. Also, you can see pressure losses and volume flow rates in here. Under section parts, you can find section parts on the selected flow path. This dimensioning is made based on applied calculations, and when you click on Adjust Nominal Diameters command, it will redimension all the system based on calculation results. And under here you can find components on this flow path. When you click on Show, it will show the part that you have selected. And right now we see the critical flow path. If you click on Search, you can select a component or a section part and you can find it on the list. When you click on Edit, you can see all technical properties and calculation results. For a swirl diffuser, you can see the room data, the pressure losses, and the sound level calculations. And you can edit, of course, the concerned part. If you click on visualization, you can color the system for different parameters. If you select the air velocity, it will color the network on a spectrum from red to blue, or you can change the color. When you click on display, as you see, it is colored. If you select the duct dimensions and click on display, it will color different duct dimensions in different colors. In the configuration tab, you can set up all presettings for the calculation. Here you can set up different values such as density and outside air property. For dimensioning, you can give different boundary conditions. You can consider air velocities for the connection and collection pipes, or you can set a table for volume flow rates and velocity limits. You can also consider the pipe friction pressure loss, or you can select both boundary conditions. As you see, you can consider both of them or one of them as you wish. Also from here you can change the unit for volume flow rate. We also have the duct and pipe tables command. In here we can select materials and limit dimensions for each types of ducts. When we limit them, they will not be used in our calculations. We can also add new values for these tables if you want. Now let's go to the labeling command. Here we have labels for each component with some parameters. If we select an air outlet, in here there are selected parameters for this label. You can select more parameters if you want to input this data into the component. If you click on OK, after you do your selection, you can click on Save Parameters in Network Components command. And here, and say it will take some minutes because there are lots of components in here. And all these parameters for each units, each consumers will be saved. Now let's select the component. And as you see, all parameters are here inside the component. Now it's time to have our output from our project. In here, in this comment dialog, you can select titles that you want to see in the output. These are calculation results that we already saw in the calculation dialog. If you click on preview, as you see, there's an empty project page because we didn't give any details about this. And we see the overview of our results. And until this one, we see the compilation of outlets for each systems. As said here, the outside air, escaping air, exhaust air, and the supply air. And when we continue, we see pressure loss calculation results for each flow paths, for supply air, escape air, exhaust air in detail. And now we start with the sound level calculation results. From here, as you see, for each flow path, we see all the calculation results for sound levels. And if you go to the end, as we will see here, the bill of quantities, the legends, and of course the material list. And now we have come to the end of this webinar. Today we constructed and calculated a ventilation system with linear solutions on Revit. I used linear desktop ventilation and analyzed ventilation modules in this webinar. If you have any opinions on our webinar, or if you have any suggestions for topics that we should cover in our next webinars, please let us know. If you need more information about this subject or linear, you can reach us via export@linear.eu. If you want to watch this or previous webinars again, you can follow linear YouTube page. Thank you very much for your participation. Now, please feel free to ask your questions.